Hello, everybody. I am talking today to Professor Nicholas Diakopolous. He is an assistant professor in the Northwestern University School of Communication, and he has written extensively about algorithms and artificial intelligence, bots, how they affect the world of journalism and how they affect all of us. So I'm really pleased to get to talk to you today, Professor Diakopolous. And I'm hoping you would just start off by telling us a little bit about how you came to do what you do.
Well, thanks so much, and thanks for having me on. I appreciate the chance to sort of engage in this course. So, my background is actually as an engineer and as a computer scientist. That's how I was educated. But I've always been really interested in media and games and photography and just how media comes about. And when I was in graduate school, I started to get interested in journalism, just because of sort of the mission of journalism, helping the public understand what's going on in the world and investigating abuses of power in government and so on. And so sort of as I went through my studies, I did a postdoc, so that's training after my PhD in a school of communication and information. And that brought me to New York City, which is sort of like the media hub of the world. And when I was there, I kind of was just soaking it all up. And I stayed for about 5 years. I did fellowships at the City University of New York in the School of Journalism and at Columbia University School of Journalism. And it's at that point where I really started getting interested in combining my interests in computer science and media and journalism and looking at how algorithms are being used in society and how algorithms exert power in society. And so after 5 years in New York, I was sort of finally ready to be a professor and spent a few years at the University of Maryland. And then last year, moved up to Northwestern University, where I teach computational and data journalism. So that's sort of what brought me here, and Northwestern is sort of a hub for computational and data journalism, and I focus on this area of kind of investigating algorithms in society.
And I'd love for you to just tell us a story about investigating an algorithm that seemed newsworthy or important in some way. And I think you tend to do it with a team of people, or a big project, and kind of how it played out.
Yeah, so obviously algorithms are being used everywhere now, but one of the earliest investigations that I was involved in was looking at the Uber surge pricing algorithm. So if you're familiar with Uber, it's an app, you press a button and a car shows up and picks you up and takes you where you want to go. So the interesting thing about Uber is that the price changes over time. It's dynamic. And so they have this algorithm which is looking at all of the transportation patterns and how many people are requesting a ride and how many cars are on the road and that are able to give rides. And it tries to balance those things out dynamically and match supply and demand. But we were sort of interested in this pricing signal. So I was working with a data scientist in my lab on this project. And what we wanted to do was understand whether or not different prices in different neighborhoods might be impacting the general price that people were having to pay in those neighborhoods, or if perhaps different neighborhoods were getting different levels of service quality by Uber. Like, say, one neighborhood maybe was able to get a car really quickly, but another neighborhood would have to wait longer for a car. So what we ended up doing was we gathered a bunch of data from each of the neighborhoods. And to do that, we sort of looked at, we did this work in Washington, D.C. So to do that, we looked at each of the census tracts in Washington, D.C. So census tract is the area, the geographic area that the national census uses to aggregate populations. So we looked at each of the geographic census areas, and we asked the Uber platform, what's the price at this location, and how long does someone have to wait for a car at this location? And we did that multiple times, like every 3 minutes, we would ping every location in Washington, D.C. So we had this very dense map of prices and how long people were waiting for cars in different neighborhoods. And now, because we had collected data for each census tract, we were then able to connect the Uber pricing data and the Uber waiting time data to all of the other demographic census information that was available, like, you know, the racial composition of the neighborhood, you know, the median income, population density, all these kinds of things. And we built statistical models that were able to control for these different variables. And so by looking at all that, we were able to sort of see whether or not Uber was being fair to different neighborhoods. You know, did some neighborhoods have to wait longer for cars than others? And were there any connections between these other demographic variables and whether or not you had to wait longer for a car? And what we found actually was that in general, the more people of color you have in a neighborhood in Washington, D.C., the longer you'd have to wait for a car. So this turned into kind of an interesting story that we ended up publishing in the Washington Post as an example of how algorithms can be unfair to different people. That, you know, just based on the racial composition of a neighborhood, you might end up waiting longer for a car.
And when you describe, you know, pinging them every 3 minutes, now I don't think Uber was like voluntarily giving you information. Were you all posing as riders and making a request and then canceling it?
Yeah, so the way that works is that in late 2014, Uber actually opened up some of its data so that you could access it via what's called an API, an application programming interface. So the API is like, it's a little gateway that you can use to request some data and then have their computers return some data. So we were able to leverage that and then write computer programs that could just repeatedly ask their API for more data every 3 minutes. So yeah, I mean, in order to do that, we basically, you know, created an account and then used that account to request data from their platform. But we weren't like using the app or something like that. It was all sort of like this automated process. And
who was involved in doing that with you?
Right. So this project was done primarily with Jennifer Stark, who was a data scientist working in my lab. She had a background as a neuroscientist, actually, in, you know, quantitative research methods, and so yeah, she came into it and was involved in the data collection and the data analysis and the statistical modeling of the data once we had collected it. And then we sort of worked together in interpreting and writing up that data, as well as, you know, we had to make phone calls to Uber and ask for their comments. So we were both sort of involved in the journalism component of it, because, you know, whenever you have a story like this where, you know, essentially we're claiming, hey, maybe the Uber algorithm is being a little racist here, or at least it's unfair to different people in different neighborhoods, you have to sort of give the corporation an opportunity to respond, right? I mean, what's their take on it? What's their read on it? So all these sort of tasks were done as part of sort of teamwork between the two of us.
Mm-hmm. Very interesting. So thinking about how this algorithms, and I assume that the Uber algorithm is secret.
It
like
is
Google,
indeed, yes.
Like, yeah, all of these, yes. And so, you know, given the ways that AI and all these algorithms, algorithmic systems are evolving, what are your kind of best outcomes that you envision in the future? What are you excited about in the possibilities of this field?
Yeah, I mean, there's a lot of good that can come out of using algorithms and machine learning. I do tend to focus on investigating these systems in society, but there's certainly a lot of good that can come as well. So, I think the biggest thing is probably just creating more efficiencies in the future. So algorithms are really good at optimizing things, like how long does something take and how much does it cost. And they're being used to good ends in a lot of domains, like making medical diagnoses more accurate, or reading images that doctors might take and helping to find like tumors in those images. And sometimes they're even more accurate than people in finding that kind of, in reading those kinds of images. So they can actually sort of not only be more efficient and save time and save money, but sometimes they can be more accurate than people as well. So it's important to sort of put these things in context and realize that they can be quite powerful and useful. I mean, I think there's interesting applications in all kinds of areas of society. In communication and journalism studies, we could talk about, translation algorithms, translating information from one language to another, so that you can access information from around the world. In my field of computational journalism, certainly there's algorithms that can help enhance the quality of journalism, the comprehensiveness of investigative journalism. We can create new interactive experiences with information and news using things like chatbots. We can help optimize the dissemination of news and the distribution of news on platforms, so that more people see more important stories or more personally relevant stories. So I think there's all kinds of sort of potentially good outcomes that can come of using algorithms in different areas of life.
And what are the outcomes that you're worried about? What are the bad outcomes?
Right. So, I mean, yeah, like I alluded to, we do, in my lab, we do tend to take more of a critical stance and think about, what are the sort of the potential negatives here. Speaking broadly about algorithms and automation and AI, I think I've heard it come up oftentimes that people are worried about, losing jobs, right? Algorithms and AI are going to take our jobs. I'm not as worried about that, perhaps, as some other people. It does depend on what field you're talking about. I think in the field of news and information and journalism, I'm not as concerned about it. Where I think, it's more the case that just the nature of work will change as a result of more AI and more algorithms being rolled out. There'll be new roles, there'll be new jobs for people to have to develop these technologies, to maintain them, to manage them, to supervise these systems. So I think if people sort of keep up their skills and are creative in terms of thinking about how they fit in with technology, I don't think that jobs are going to be a huge issue. Like, I don't think we're looking at a world where all these algorithms are going to put everyone out of work. I guess what I'm more worried about is whether, sort of along the lines of the Uber story, whether algorithms and machine learning is going to be fair for people. If you think about an algorithm that is, some kind of medical algorithm that's looking at a medical image and helping to diagnose a cancer, that could be really fantastic, right? If it helps save lives. But imagine now that all the data that's used to train this system comes from a really affluent, really white hospital. And we know that medically, it's been shown that if you just train the system on that type of data, it could work less well for other demographics and other populations, because different demographics have different genes and different risk profiles for getting cancer, let's say. So we need to be really careful about, as we build these systems, we've just got to think carefully about who gets to benefit, and we need to try to maximize that benefit so that more people have positive outcomes from the technology. And I mean, it's not just about fairness, right? I mean, there's other bad outcomes that can come about as a result of AI and algorithms. I mean, in general, we just sort of need to make sure that they're that they're reliable, that they're not making expensive or hurtful mistakes or errors, and so that they're not misused by people in ways that they weren't designed to be used. There's this great investigative news story that ProPublica published in 2016, where they actually looked at the use of criminal risk assessment scores in the criminal justice system. So a risk assessment score basically takes a bunch of information about someone who's been arrested and tries to figure out whether or not they're a high risk for being a repeat offender, or if they're a low risk for being a repeat offender. So it sort of scores you on a scale from 1 to 10. How likely are you going to be to engage in criminal behavior again? I mean, it was a very, very interesting story, and they found that these risk assessment scores were sort of racially biased, so that Black people were tended to be scored as higher risk than white people. But the other interesting thing that I think that came out of that story is just that the corporation who created the algorithm that makes the score, they actually had two versions of the score. They have a version of the score for men, and they have the version of the score for women. And that's because the way that we think about the sort of criminogenic needs of men versus women and how they're reformed, I guess, in the criminal justice system, it made sense to sort of have one version of the score for men and one version of the score for women. But it turned out that, where they were investigating this story in Florida, that that county in Florida, Broward County, was actually misusing the score. So they were using the score for men, but they were applying it to women. And that in and of itself is just, sort of another example of this sort of misuse of an algorithm. I mean, even the corporation that created the score said, hey, don't use the same score for men and women. But then when it was implemented and deployed in the county, they were misusing it. So, I mean, we just have to be very aware of sort of making sure that the tech is fair, that's not being misused, and that we're generally on top of just making sure that people aren't getting hurt by these systems.
Can you think of any examples of societies, where they're doing a good job of keeping an eye on that sort of thing? Of I don't know whether it's through regulation or through journalism, or are there any good models for responsible and effective use of algorithms?
I think we're still figuring it out. I mean, this is a very recent area of development and research. I mean, I think we're starting to figure it out in the U.S. I mean, I think we're starting to see. I was just in the UK last week and in Germany last week, and we're starting to see movements there where people are a lot more aware of this. There's certainly movements throughout the European Union, I would say, where people are kind of waking up and are trying to keep better tabs on what's going on in terms of the use of algorithms. One thing we've done in my lab at Northwestern is develop a site called Algorithm Tips. So algorithmtips.org if you want to check it out online. And what it is it's sort of a resource page with examples of investigations of algorithms, some methodological resources for if you wanted to investigate an algorithm, how would you go about doing that? And then we also have a database. So we try to track all of the different examples that we can find of different government agencies using algorithms in decision-making processes. So we're really trying to do a better job of just catalog all these things, bring them to light, and make it easier for journalists or for other people in civil society to sort of find these things and pursue them and tell the public about them.
I'm going to guess that the need for journalists who can do this kind of work far outstrips the supply. at this point of such journalists who can do the coding and understand the algorithms and do this forensic process?
Yeah, I think that's a fair I think that's a fair assertion. It's it's a a nascent area. There's a lot of there's a fair bit of skill I think you often need in order to investigate these systems. And we're sort of at a point where we're starting to think about how to build capacity for doing more of these investigations. Can we do more trainings? Can we develop data skills and computational skills for journalists so that they can feel more competent and confident in pursuing these types of investigations and so on. So yeah, I would say we're still sort of in the early days of I guess the societal capacity for investigating these things. So it's a good growth area for students to get into if they're interested in really digging into societal issues of technology.
And what about for those of us who maybe don't see ourselves going into that field or necessarily becoming crack coders or whatever? Is there a kind of baseline knowledge or understanding that you think all citizens are going to kind of need in the future?
Yeah, I think that's a good question. I mean, I think that there, if you want to go really deep on this stuff, there is a lot that you could know about algorithms and machine learning. Obviously you can go get a degree, you can get a PhD in computer science, you can get a degree in information science, and learn a lot about this stuff. When I teach some of my courses on data journalism and algorithmic news media at Northwestern, I try to encourage my students to develop computational thinking and data thinking. And I think those are sort of good ways maybe for thinking about like what's the base level of sort of literacy that we might want in society for people to be able to understand these things. So when I say computational thinking, what do I mean? Well, I'm not talking about thinking like a computer. What I really mean is thinking in a way that you're able to formulate problems and solutions in terms of how those solutions could be implemented on a computer. So computational thinkers are able to sort of think about and exploit the capabilities of algorithms and automation to accomplish their goals. So that's sort of what I mean by computational thinking, and that might involve at one level maybe understanding a little bit about code. But it's not necessarily about being able to code. It's sort of more like, do I understand what the computer can do and what kind of problems it can solve? Do I understand how to decompose a problem so it could be solved by a computer, and so on? So I think to jump back to my point about jobs and so on. Like I think if you want to get ahead of the technology and really be one of those managers or supervisors of technology, being able to think computationally means that you're sort of in command of all the different things the computer could do, and so that means that you can manage that technology more effectively. The other thing that I try to teach my students is what I call data thinking, so kind of a form of data literacy, I guess you could say. But basically what I mean there is you have to sort of be able to understand like every stage of data production and use. So like how is data collected? How is it manipulated? How do you sample data? How do you clean data? Because oftentimes data gets very dirty and messy. How do you transform it from one type of data to another type of data? How do you ask questions of it? How do you query it? How do you validate it to make sure that it's sort of sound? And then, once you've got all that, like understanding how data reflects the world, how is data used to represent the world? how can you visualize data, all these kinds of things. So I think, if you sort of have both of those things, if you understand where data comes from and how it can be used, and if you understand sort of how computers can be used to solve problems, you put those together, and I think you've got it. I think you've sort of got that, that understanding that allows you to think sort of dynamically and critically about what algorithms can do and what can go wrong with algorithms, and also, what can go right with algorithms as well.
That sounds like a really great topic for a college course. The sort of like data and computational thinking course for humanities majors, or things like that. I don't know if it exists yet, but
well, I mean, that's similar to the course I'm teaching. So I taught a course in the spring. I call it algorithmic news media, but it really is sort of a course for communication studies students and journalism students. So these are not necessarily technical students. These are people who, students who are just interested in technology perhaps, but sort of coming at it from the angle of journalism or communications. And so, I teach them about these different ways of thinking about technology. And so far it's been really interesting, and I think really impressive what they've come up with. Sometimes I give students like new technologies, and I ask them to kind of think creatively and develop scenarios for how that technology can be used. And that's a really fun exercise where you get to kind of just explore all these ideas and also be potentially almost a little sci-fi about it. So, you take a new technology and you think like, well, let me write a story about like what could go horribly wrong with this technology, or what could go horribly right with this technology. How could it be used for great things as well? And I find that sort of storytelling, so that's kind of the more of the communication journalism way of doing things. But I find that kind of writing stories and helps develop these ideas and also crystallize them and make them more concrete in terms of connecting all that conceptual stuff about computing and data into something real.
Well, Professor Diakopolous, thank you so much for talking to us today. This is a really interesting interview, and students will be invited to post responses and questions online after they watch this. And I understand that you're going to be going in and looking at their responses and maybe giving them some further information.
Absolutely, yeah. Thank you so much for the opportunity. It's been a pleasure chatting with you, and yeah, I'm looking forward to the questions that folks put in, and I'll be checking online for those.
Great, thanks so much. Bye-bye.
Thank you.